we go. So we're on to our last little topic here before we end the unit. You guys know about isosceles, equilateral, all different types of triangles we've talked about this unit. Now what I want to do is put them on a graph. But here's the catch. I do not want the points to be numbers. The points will be variables now. All right, so 2, 2, 3, comma, -4. I don't want those anymore. I want actual variable coordinates. So here's the deal today. I am going to give you a type of triangle with a certain requirement. And I want you to put it on the graph with the proper variable coordinates. All right, variable coordinates. Take a look at the first one, and I'll talk about some tips up top. So take a look at the first one. I need what type of triangle? A right triangle, ABC. And the legs are going to be AC and AB. So if the legs, I just drew a random one out here, and you don't need to do this. I just want you to see what it's going to look like over here soon. The legs are AC and AB, meaning what's got to be the right angle? What letter should be at the right angle? A. Okay, so I got AC and I got AB for the legs. Everyone's in agreement? And again, I'm just showing you what it looks like. We don't have to copy it down. How long does AC have to be? 2A units long. Not 4 units, not 10 units. 2A. Here come the variables. And how long does AB have to be? 2B. All right. So I need to take this, place it over here on the coordinate grid with the proper coordinates for A, B, and C. So these come out to be what they should be. 2A and 2B. Tips to do this. Some tips. First one is try to place a vertice at the origin. Okay? Try to place a vertice at the origin. Second tip, try to put at least one side. I said at least because you can put both. Try to put at least one side on one of the axes. Third and final tip, try to keep it in the first quadrant. Why do you think I say that? Try to keep it in the first quadrant. Hugh? All coordinates are positive in the first quadrant. I don't have to deal with any negative business, all right? All coordinates are positive in the first. And there's tip 4, but we'll get to that tomorrow. Here's what I want you to focus on now. Place one of them at the origin. Can I place at least one side on the axes and then try to keep it in the first quadrant? All right, so I said, hey, let's try to put one vertex at the origin. What coordinate do you think we should put at the origin? A, good idea. And again, why should I put A here? Because, oh, take a look. The y and the x-axis make what type of angle already? A right angle already. So A is going to be 0.00, and that's the only number coordinate you're allowed. So where should I place AB then? On the x-axis. You could place it on the y. We decided to draw it like this. All right. So I'll place it on the x-axis, point B. Okay, now we need to give a coordinate to point B. Well, first, let's talk about the y coordinate here. The y coordinate. It's on what axis? The x-axis. And any coordinate on the x-axis will have a y coordinate of what? 0. All right, you guys are good. You're flying. 0. Now we got to talk about the x coordinate. How long does AB have to be according to my requirements? 2B, right? So how far over on the x-axis must I go? 2B. So point B is going to be 2B, 0. Again, I'm going over 2B. So this distance right here would be 2B. Where do you suggest I put AC? On the y-axis. So let's put C here. And if it's on the y-axis, think about all your points on the y-axis. What do you know about their x-coordinates? They're all 0. All 0. And then, how long does AC have to be? 2A, so I need to go up a distance of what on the y-axis? 2A on the y-axis for a coordinate of 2A. And there is my right triangle, ABC, with the requirements already satisfied. This is a length of 2B. This is a length of 2A. Yeah. Is that the only triangle I can make? No. We could put it in different quadrants if we wanted to and make some negative and positive. But again, in the first quadrant, it's easy to deal with. Everything's positive. Questions from you guys? Anything? All right, right triangles are easy. Go on the Y, go on the X, you're all set. No big deal. All right, here comes the next little tricky one, though, and that is what type? Ooh, isosceles. What do we know about isosceles? Two congruent sides and angles. The angles we don't care about here. It's the two congruent sides. I threw in a little vocabulary term. If you guys have to look back in your packet, go right ahead. But what is the base of an isosceles triangle referring to? And don't tell me bottom. That's the middle school thinking. All right, the base is the what for the isosceles triangle. How can you describe what the base is, Nick? It's the outcast side. Absolutely. It's the side that's not congruent to the other two. So FG's got to be the side that's not congruent to the other two. So if these two are congruent, this would be FG. All right, and again, I'm just giving a little sketch out for you. How long does FG have to be? 2A units. Doesn't say anything about the congruent sides. All right, no big deal. So do you think I can put this on the graph now? Where should I put FG to make our lives a lot easier? Remember one of my tips, put it where? Okay, I like it. So I'll put F at the origin. Always try to put one at the origin. I'll put, you said G on the x-axis. All right, now I'm going to start turning it over to you guys now. What should be the point of G then? Because remember, FG has to be 2A units long. So here's where I'm going to turn it over to you guys. So what should point G be? Here we go. Let's go 7. Hi, Amy. What should point G be? Don't worry about point H yet. 2A, comma, 0. Again, it's on the x-axis, so the y-coordinate's got to be 0. Why'd she pick 2A? Because the distance has to be 2A. All right, we still got one more point, which is what? H. All right? I can't put H anywhere I want. It's got to be what type of triangle? Isosceles. So where do you think is a good place to put H? Probably not right here on the x-axis, right? Because that's not really going to form a triangle. All right, but remember, wherever I put H, those two sides have to be the same distance. Okay? So where should I put H up here? Hugh, got a suggestion? I'll take anything. I'm not sure about the Y, but I know the X should be 1A. So you're saying so these two lines, so FH and HG are congruent, put H halfway in between F and G. Everyone agree? So do I. So I'm just going to put it halfway. What's its X coordinate if it's halfway? Between 0 and 2, halfway between 0 and 2A would be 1A, yep. Now, Hugh made a comment. I don't know if anybody heard him, but he made a comment before he told me the answer, which was, I'm not too sure about the Y. Well, let me ask you this. If I put H down here, would these still two be congruent? What if I put H way up here? Down here? What am I trying to tell you? Does the Y matter? No, it does not. So we can call the Y anything we want. All right, probably not negative though, right? Because we're in the first quadrant. So if you want to go whatever your favorite letter is, B, D, 2A, 3B, whatever you want to put. The Y coordinate does not matter, but just make sure it's positive because we're in the first quadrant. It could be any letter. Remember, because what we just said, Kevin, it could be anywhere on the Y-axis, right? Just as long as, since we're in the first quadrant, the only requirement I have is it's positive. Okay, if you want to put a Z there, put a Z there. If you want to put 2C there, put 2C there. And there is our isosceles triangle. All right. Could we have put that other places? Yes. But again, I'm just sticking to the tips I gave you. Try to put it on the axes, start at 0, 0, try to stay in the first quadrant. Anything from you guys right now? Going? Okay, so now I'm going to do 3 quick examples where I give you the type of triangle I want. But I made up the coordinates but left some of them missing. All right, I left a couple of the coordinates missing, so let's see if you can fill it in for me. All right, this first one, we're back to isosceles triangle. All right, I got a bunch of question marks. Those are question marks. All right, I don't know if you guys see that or not. Some years I get their 7s. Okay, those are question marks. Fill in the remaining coordinates. And just so you know here, just so you know, on this one, xy is congruent to yz. Okay, because it is isosceles, I needed to tell you what sides were congruent, because don't automatically assume it's the right and left. All right, so xy congruent to yz. So it looks like we need coordinate x, we need coordinate y, we need z, but I partially gave you z, was a comma something. All right, let's fill it in with each other. What are the missing? Remember, it's isosceles, so be careful what you say here. It's isosceles. All right, let's roll. Here we go. 11. Ready to go? 11? Okay, let's get x out of the way. 0, 0. Let's get the y coordinate of z out of the way. A comma, it's on the x-axis, remember. Oh, z. I'm not on point y yet. Point z. I told you the x coordinates a would be 0, yep. Okay, now let's go to y. It's isosceles, so the x coordinate's got to be halfway in between. Which 0.5a, 1/2a, a over 2, whatever's floating in your boat, guys. I don't care how you write it. And then the y coordinate, anything, all right? Anything other than a negative. We all good? Okay, now, little change up. Not only do I want it to be isosceles, but I want it to be a right isosceles triangle. Which two sides are congruent? I shouldn't have to tell you which two sides. Which two sides up here are going to be congruent? The legs, yep, they have to be. Because remember, the hypotenuse is the longest side, so can't have two sides equal to the longest side. All right, so let's go B. Let's go C. And A. And I gave you C's x coordinate. Okay, let's do this. Remember, isosceles right. So we got to be careful now with our x's. All right, let's do this. Maybe 12? Okay, here we go. Am I ready? I'll start off easy. Point B. 0, 0, y coordinate of point C. Okay, here we go. It's got to be isosceles. How long is this leg here from B to C? Oh, look at your x coordinates. How long is it from A to C here, or B to C? Okay, this is 0, 0. This is what coordinate? So how far did I go over on the x-axis? 1a, right? So this is a length of a. And if it's going to be isosceles, this has to be a length of, okay, so make sure you give me a correct coordinate so it'll be the length of a. So it'll be what? 0a. Does everyone see that? You can't call this y coordinate whatever you want. It's got to be a, because both of them have to have a length of a. Is that tricky here? We okay? Because this next one's I'm blowing people out of the water with the algebra we have to do on the next one. Anything? Okay. What type of triangle are we dealing with on the next one? All right, that changes. That's a whole new ball game. Not isosceles anymore. Whole new ball game. So can we just get W out of the way? 0, 0. Y is already given to us. Ready for Z. Well, let's go x coordinate of Z first. Well, why? Because 2a, or 1a is half 2a. Yes. In between 0 and 2a, halfway is a. Now, unlike isosceles, do you agree the y coordinate matters? Because watch, if I lower point Z, is that going to be equilateral anymore? No, it'll be isosceles, but it won't be equilateral. So the y coordinate matters now. I need a certain y coordinate, and the question is, how the heck do you get it? All right, strap on your algebra pants. Here we go. Here's how we're going to find the y coordinate. Does everybody agree this distance right here of this line segment I just drew in is going to be where on the y-axis I need? Are we all in agreement with that first part there? Because I don't want to go too fast here. The length of this segment will be the y-coordinate. If it's 4, we went up 4. If it's 10, we went up 10. We're all in agreement. Okay. I just formed, this is the x-axis, right? And this is basically my y-axis. What did I just form right here then? What did I just form right here? A right angle. Yeah. So I formed 2 right triangles there. And I only want you to focus on one of them for me. Here's where I need your help. We said if you can find me this distance, which I'm going to call y, that's my y-coordinate. Are we all in that agreement? Whatever that distance is, that's my y-coordinate. Could you help me, please? Does anybody know the length of this line segment? From here to here. Remember, I'm halfway here. From here to here, well, from here to here is how long? 2a. So each piece here is going to be how long? Okay, nice. Can anybody help me find the length of the hypotenuse? What type of triangle is this? Right. No, excuse me, my bad. The original triangle is a equilateral. How long is one side already? 2a. How long are the other 2 sides? If you have 2 sides that you know of a right triangle and you're trying to find the third, you have always used what? If you know 2 sides of any right triangle and you're trying to find the third, you've always used this. Cameron? Pythagorean theorem, right? You've always used that to find the third side. And you're probably thinking, how the heck do I use Pythag with the a's and the y's? We're going to. All right? A squared, b squared. Here we go. Strap on your algebra boots. Let's roll. Give me a leg. Name a leg. Okay, so I'll keep that a squared. Name the other leg. Other leg. Name the hypotenuse. Oh, whoa! Incorrect what I wrote up here. Who's going to dig deep and tell me why that's incorrect what I just wrote up here? What am I squaring by writing that? Just the a, not the hypotenuse. What's the hypotenuse length? So I need to square 2a, not just a. I need to square 2a. All right, I know you're a little nervous. Sweating probably. Anxiety through the roof because I have a's and y's in there. Let's deal with it. There's nothing much I can do here. But you can take your algebra skills, 2a all squared. 2a and another 2a. 2a all squared. Come on, from last year. We know it's not 2a squared. Come on, Will, help us out. 4a squared. Who'd you have last year, Will? Okay, I'll let her know. What? 2a squared. What's 2 squared? A squared. A squared. I'm done squaring. Okay. What are we solving for? What are we trying to find the value of? Y, right? Well, I got to get that out of the way then. How? Get it over. Subtract it. Go. Minus a squared. Minus a squared. Oh boy, I'm really nervous to ask this question now. 4a squared minus a squared. If you tell me 4, leave the room immediately. The a squareds just don't cancel out. If you have 4a squareds in front of you, and I come by and I snag one of them. How many a squareds do you have now in front of you? 3 a squareds. Okay, how are you going to get the y by itself? All right, here we go. And you're like, I'm nervous. Should be. So let's finally find this y coordinate. Now, I cannot take the square root of 3a squared, but I can take the square root of something that's inside there. Not the whole thing, but I can take the square root of something inside there. What can I take the square root of? A squared. What's the square root of a squared? A, and what's still underneath the radical? What's still underneath the radical? There's your y coordinate, a radical 3. Woohoo! Now, so you don't have to do that over and over again tonight when you are faced with an equilateral triangle. Watch, ready? Let's say instead, it's 2b. Guess what your y coordinate's going to be? 2b, radical 3. You're just taking whatever the x coordinate is and putting a radical 3 with it. Do you see that? Yes, no, maybe? So here you go, ready? Let's try this again. Let's say my z coordinate that's halfway in between is 4c. What's your y coordinate? 4c, radical 3. That's only for equilateral, though. What? Equilateral, yes. Yes, equilateral. Okay? So if you don't need to go through all this again, you can just say, oh, I just multiply the x coordinate by radical 3. You got it. All right? Okay, you guys are on your own. You're probably going to get the homework done, I believe.